Turn the sound up just a bit. Talking kind of quiet, I guess. Anyway. Um. All right. Good morning, and welcome. I am a couple of minutes early. Oh, I need to get the link still. That. Okay. Links are posted. Yes. So welcome. Good morning. Did not fill my. I have to do that here in a little bit. Fill up my water, but that's all right. We'll keep rolling for now. For anybody new, first of all, welcome. Thanks for watching. My name is Tim. I go by FoamyGuy on GitHub and Discord. I'm working on some CircuitPython stuff. Most typically, that's what I do on this stream around this time each week, 10 a.m. Central Time. We're a few minutes early this week, but around this time is usually when I start. And if you don't know what CircuitPython is, you can learn more at the main website for the project, circuitpython.org. This is basically a version of Python that runs on tiny computers called microcontrollers. I have a PyPortal one, which is here on the camera running this thing, which is what I'm working on. It looks kind of dark because, well, the screen is all white, which puts off a lot of light, and the camera can't really pick up the rest. And I don't have any other direct light on it, so you can't see it very well, but it's the same device as this, which you also can't see very well because it's inside of a thing, but here you can get a better sense for it. Essentially, it's just got a little touchscreen on a PCB, and it's got a couple other sensors and things there. So this one is almost like a little tablet, but these microcontroller devices, there are almost 560 of them that support CircuitPython, and they do come in all different shapes and sizes. I'm using the PyPortal with the display on it today because I'm working on a display thing, but lots of these are just general purpose, and they have pins which you connect whatever you want to use to. But there are some that are more purpose-built with things built in, like the keys on this one and a knob and a little screen for making a macro pad, a little handheld game or conference badge type thing there. There's all kinds of different ones of these. All of these ones on this page run CircuitPython, which is kind of the unifying theme of my streams. I'm always typically working on stuff somehow related to CircuitPython. We do touch a lot of different areas. This week with a bit of a project, which will go into a Learn guide. And so I did start this last week. If anyone is interested and you want to go back to see the precursor, so to speak, the what do they call that? The prequel. If you want to see the prequel to this, if you found this stream interesting and you're watching it, you can go find last week's on the same YouTube, and that's where I basically started this project. So you can kind of get the history on where we're at and what we're doing. The really, really quick version is we are implementing Karel the robot, which is a thing invented by this person from Stanford, which is a tool for teaching people programming by giving you control over this robot in a little world environment with a couple of different bits and bobs that it can do. Pick up the beeper and put it down and avoid the walls and such. And I'm going to start today with upping the size of the sprites. I made a new sprite sheet that is a bit bigger, and I want to use that. I did do a little bit off the stream. The thing that I did off the stream essentially was oh, this is the wrong place to paste it. The thing I did off stream was at least start to, maybe fully. I don't know if it's working all the way. It's not fully tested. So I implemented the ability to put multiple beepers on the same tile, which they call corners. Yeah, corners. Which is what led me to wanting to increase the size of the sprite sheet, because when you put multiple beepers on the same corner, it adds a little number in the middle of the beepers. One of these does, yeah. So like this one here has got the 42 in there. And with the sprite sheets that I was using, which were 16 by 16 for the sprites, the number was kind of too big. It was basically touching the edge of the beeper. And I'm hoping that by going to 24 by 24, we'll be able to have at least 2 digits before it starts touching the edges of the beeper. That's my hope. I don't know if we'll actually get there, but yeah, so we can get into Karel. And so firstly, we have probably a bunch of places where this is hard-coded to 16. I think what I'm going to just do is make a tile size 24, and we'll just assume the tiles are square. And then we'll use tile size everywhere where we had 16. Oops. Started copying instead of pasting. I could do replace, I guess. Okay, I didn't pay super close attention, but I'm pretty sure all of those 16s were 16 because it's the tile size. Oh, not that one. Actually, that's true. No, yeah, that one too, in fact. It seems weird because it's a scale. But that's the background, and that's a little bit of a cheat that I used on the background. It's not really a cheat, but like I made the background really small and then scaled it up, so technically it doesn't use very much memory. Yeah, I think those all look good to me. Okay. And then we should have the sprite sheet somewhere. Sprite sheet, there it is. Okay, so actually one other thing that I did do off stream, I don't think I did this last week on the stream. I added some diagonal lines to this. I think we just had these clear last week. But I think the diagonal lines are a nice touch to indicate that there are like boxes that you cannot walk over. I change this to 24. I think auto reload's probably not on. Okay, yes, and then that's much bigger, which is nice. What is not as nice is we cannot see bottom now. I think did hard code, yeah, these, but this is just in the world constructor. We could actually change it. But I think I'm just going to change the default for now. What is 320 over 24? 13 and a third. Okay, well, we'll just do 13 by 10. So for my PyPortal, that's how much can fit. We'll get index out of range because it tried to like move some stuff to the bottom. There, like all of these 14s can't be 14s anymore. Those should now be like, no, 10, 9. They should be 9s. 9s? 0 through 9 gets you to 10. Yeah, those should be 9s. And this also. Okay, there we go. Okay, so yeah, you could see there I was actually testing the multi-beeper a tiny bit, but not very much, and it was still off-center, but I think that's because there's another hard-coded 60. But there, it would be, I made a update, in fact, it's right there, update beeper. Oh, right, so this 8 right here is actually 8 because it was half of the tile size. So yeah, there was one more usage, but it's divided by, so we could do int. Yeah, there we go. It's probably not going to fit 2 digits, but it will maybe be legible. Like, not fit 2 digits without touching the edges, I mean, but it will maybe at least still be legible. Or I'm just going to make this for I in range just 3. That's going to put 60 of them. Oh, I did also make it so there's a way where you can put beepers before you pick them up. Because I noticed the one on the site, at least in some of the examples, allows you to place more than you've picked up. Allows you to place infinite as far as I can tell, although I didn't push it. Actually, we are not touching the edges with 2 digits. Maybe the 7 is touching just a tiny bit, but yeah, it's totally legible. That's nice. So I definitely like the 24. The other thing about 24, it will let you still do 10 by 10 on like a funhouse or a gizmo display, which are 240 by 240. So being able to still do 10 by 10 still gets you a lot. Basically, you can do a lot of different examples and stuff with 10 by 10 still. So okay, that was fairly easy. Next thing to do, I think, is gonna be I think loading the state, loading the starting state, and figuring out if and or how I want to deal with the ending state. Is like in all of these examples, they give you get a starting state and then you get a goal state essentially. That's kind of a common theme. It would be nice really to maybe have a way to also have a goal state. Check against the goal state or something. let's worry about loading first. So I think what I would like to do is just have a load state function on the world, because the world the world has Karel. Yeah, so Karel's location is part of the initial state. Need could ultimately pass it into the init, but I think I want to just do this, and then state's basically going to be it's going to be a list of lists that represent the world you want. Each item in the list will be tile number in the sprite sheet. And then the one extra piece of information that we need is the number of beepers. So we'll have one other thing like beeper count. Which will be a dictionary of tuples that are like locations to counts. So if there were 39 beepers at location 00, it would look something like this, and it will only contain entries for ones that have more than one, because any that have one or less we don't care about because they don't show the number. And that should be everything we need, I think, for the state. In order to do that, we are going to go and loop over the rows inside of the state object world. So for row in, I'm actually going to do for, I think we want the number as well. Enumerate. So for y enumerate, that's going to be state world. And then, yeah, probably, yeah. And so those are going to be numbers, and we can basically just take those numbers and put them into the world tile grid at the same location. That goes X. Cell value. Self. They did here because it's not inside of world actually. Before that, which outside also. And then actually beeper counts. No, beeper counts is actually also a list. think there was a reason that I didn't make that just the dictionary, or what it was. The labels is a dictionary, which work with the tuples like I was saying about the state object. Dictionary of tuples, I guess, is a little annoying in that you have to iterate them all randomly instead of just one. I don't know why I chose that, but that's fine. I think stick with it for now, and if there's a reason to change it, we can. So we're actually inside of, well, we could say if xy in the state object. So I think I'll also say if beeper counts in state object and xy in state object beeper counts. So if beeper counts exists and if the current location is in beeper counts, then go ahead and say self dot counts. This has to be yx because it's a list of lists. Equals. Go. One other thing we probably need to do is actually just empty out beeper counts. Otherwise, it could have leftover stuff that we don't want. Def init beeper counts. And height seems it from there, but we can. Maybe go back and just save that as world.width or something. Yeah, we should empty this out as well, I think. Move them all from the group. And then we set this back to empty, set this back to empty, and then we go and fill it with zeros. So this can just call init beeper counts, and also inside of init should do. You don't need this one, self.init beeper. Don't really need to print this either. Working, I guess. Let's see. If it's not working, then it would not let current test script work right, potentially. So let's just run that and see if it works. World object. Okay, no, it doesn't have labels. Oh, it tries, doesn't exist. I guess we go. Only do it if it's not none. Get none before restart. Okay. Like the counts are working fine. Okay. That should work, honestly. So I'm gonna make a... One should we use first? Start with this one, I guess. Just... And by chapters, chapter 2... What state? Karel... 02. So there's... What state? One, I don't remember actually. So default is 0, 1, 2, 3, 4, 5. We could just maybe object equals dictionary object world. It's a list. By range 10. So we're going 10 by 13 to match the display, or should by 10? It will on the smaller. I think I'm actually just gonna do 10 by 10. It's in range 10. Then actually, I wish I could go back up, but I really can't now. Okay. Was that faster than typing it out? Never know. This so that it's a grid. Okay, so Karel is bottom left, and then a beeper, and then a blank, and then yeah, we'll just do nothing for the, so we're 10 by 10, even though this is smaller, but we'll just put, it'll just have blank corners outside of that. That's fine. So those are what? Karel going which direction is left? No, right. That's 0. Beeper is going to be 4. empty space, and then wall block thing, which is 5, 6. There's 3 of them in a row. Pull this stuff off. And go world.loadState with open open the file and then load it. Nice. Let's make sure that it actually worked for real by changing this. Add some more of these. Let's just take this all the way to 10. Error word. Okay. Word. World. Okay, yeah, did not work then? Karel can't move there. Oh. Oh. Okay, hold on. We filled in the world, but we need to treat Karel differently. Yeah. So actually, when we find Karel, so we need to actually not do this if cell, actually have a whole range of them. We need to check for all 4 of these. And we actually set the direction based on it, so I suppose we might as well just check for each of the 4 in an if statement. So 0, 1, 2, and 3, we have special behavior for. If cell equals 0, then we are gonna say self.Karel, say x equals x and y equals y. And direction, so 0 is west, no, east. Okay. And then these will be very much basically the same, where that's going to be 1, which is up, north, north. 2, west, and south. And then only if it was not any of those do we want to set it to cell, because we actually don't want to set the Karel tile in the world. In the world, it should actually just be a 5. It should just be blank. But I will have to put it in all 4 places if I do it here, so I guess I'm gonna put it up there, but that's just gonna make it run a bunch of extra time, so I guess we're gonna do this. We still ended up with Karel icon in the world, which is odd. mean, cell should have only been 0 on one location. It was 0. We should have set the world tile to corner. Karel's location seems... that part seemed to work. Oh, this else, I get it, I get it. This needs to be elif, elif, elif. Yeah. Okay. It needs to be one big logic tree. Okay. Maybe we should just make this 10, in fact. Maybe the default size should just be 10 by 10. All right. We can load state. I think I would like a way to basically try to check the goal state. So like if this is our goal state, I want to also feed this in. So maybe this shouldn't be called input state. Maybe this should just be called Karel chapter 2. Or Karel chapter 2 state, and it can contain both. We even need to specify state. We have load state, and we'll have, I guess, check goal state. Let's just make this chapter 2 without anything else. And then let's actually tweak it a little bit to have input equals an object with world. Then this object can also have beeper count. Ugh. Not even gonna. I don't even know why you would want. That's the appropriate way to display that. Okay, so we have input world, so we'll need to also, when we load state, make sure that we look for the input. Actually, we could take all of input. Have goal out. So the goal is Karel on the third, standing on top of essentially the third box, and the beeper behind. So that's blank. That's blank now. Karel is here facing east, so 0. And the beeper is 1 behind, so beeper is 4. That's the goal, I think. Okay. And then let's turn all of this stuff off, which is doing all of the weird testing on putting beepers a bunch of times. And I guess we could just actually try to do this again. Or maybe this first part of this? Yeah, actually this first part of this is it. So 1 step forward, pick up the beeper, 1 step forward, turn left, Go up 1 now, turn right, go forward 2, put the beeper down, go forward 1. Yeah, so that's everything we want. So theoretically, check goal state. I guess we could have kept that maybe. Your object equals C. Your object equals. Is JSON.load F? So I noticed that it recommended that. Is that a thing? Is that better somehow? I guess it's less typing. Object. Okay, this way we will keep our chapter object around, and then we can pass it here. Yeah. This doesn't need to be inside anymore. Okay. We're gonna need that same big branch of logic. Check goal state object. Okay, we're not doing anything with beeper counts. We are going to. We are still gonna loop X and Y, but we don't. It's not a list of lists anymore. We don't have access to like complete rows. We can't just enumerate them. So I think what we do is just go for Y in range. The length of. I'm going to go back and save the width and height of the world. Somewhere we used the bitmap for that. Shouldn't be an enumerate anymore. We don't actually, yeah, we don't need length. We can just say for Y in range of world width, world height, I mean. And then X will be in range world width. And then we can either loop over the tile grid, the world tile grid, or we could loop over the goal state and check them against each other, ultimately, is what we're trying to do. I will be right back. I'm gonna run to the restroom and fill up my water, so it will be 1 minute, but then I'll be back. Okay. Guess we might as well loop. How's it going, Jose? Nice to see you, my friend. I guess we might as well loop the. I think we might as well loop the object, the state object. That way, it's pretty much the same as the load state function. So goal cell index is state object goal. Just do goal by itself. Yeah. Goal world. And then it will be yx again because it's a list of lists. And then we say if yeah, we are going to need basically the same logic essentially because we need to translate between the tile numbers and what they mean for Karel essentially. But we can bail earlier. Can we? I don't think we do this. Pull those back. Change this out for that. We'll be having different stuff in here. And I maybe want to do the else first. So else if it's not Karel, then we are going to check and see if world tile grid, then we're back to XY is equal, I'm going to say not equal, actually. If it's not equal to the goal cell index, then we return false. Did not meet the goal state. We found one that's not the same. That wasn't Karel. Yeah, Karel. We'll actually also need one more of these for the beepers as well, which we'll need in the load state actually too. Will we? We don't actually need it in the load state because we can loop that thing separately. Yeah, actually we don't really need it here either, in fact. I mean, we could put it there and it would let us maybe bail earlier, but okay. So basically we want to say if Karel's not at this location, we are going to be returning false because we don't match the goal state because we found Karel here in the goal state. We will also be checking the direction. So or direction does not equal east. All of those are return false. And the rest of these are pretty much the same, except the directions are different. So we go from east, I think, to north, and then to west, then to south. That should validate that our Karel is in the right spot and facing the right direction. This should validate that all the rest of our tiles are correct, which mostly means beepers. And then we will also still say state object, beeper counts, So what we're going to do here is say if beeper counts yx is not equal to the count that is in state object goal beeper counts. These should all have goals in them. That's not equal to that. Return false. Get rid of that. At the end of everything, if we have passed all the tests, we return true. This should be here and also here. If I change that on the load one, actually. Yeah, actually, I didn't fix that on the input, put. Okay. Okay, so that should return true if everything actually works. I changed the name of the file. But it would, I thought I did shift refactor. I thought it would change it for me. True. Nice. And then if we like had an extra move here, it would no longer be true, hopefully. Uh-oh. Beeper location even work? Oh, no, it's true even before anything happens. So that's just not working. Okay. When in doubt, print it out, I guess. What's up, Gordy G? Nice to see you, my friend. Why is... Put it after this. Well, but let's put it actually... Oh, okay. Let's say goal is this. And actual that. Could the goal state not Karel? Karel is just beepers and paint colors? I mean, it certainly could, but I feel like it's more in the spirit of it to also check Karel. On this one, it does sort of happen that mostly the beeper is the thing that is of interest, but On some of them, they're more, I forget which one it was. Functions, maybe? No, I don't know. One of them is a bit more about where Karel is at. And yeah, I haven't gotten into the colors yet either, but we could ultimately check the color state as well. Although it will, color state will, that will actually be a fair amount trickier. It can definitely be done. Anything that's like, can it do this? It definitely can, but color state will be a bit trickier because the colors are not part of the, they're not part of the tiles. So right now our goal state is integers that map with the tiles in the sprite. Basically, we would need a whole nother list of lists filled with colors. And if you had that, then we could check the colors. But it would mean that the chapter files actually ultimately need to have an extra list, basically. An extra list of lists, an extra grid of the entire board. Okay, what are these printing? Printing anything. Not printing anything. Oh, okay. Well, for one thing, we were returning inside the for loop, so that's not good. But also, why did we not get any of these? Oh, we did. We got one. Okay. Okay. It should be all the way back there. Could the goal stay? Oh, right. Oh, to allow for other solutions. Could the goal so could the goal state care/not care about any particular objects? I mean, like ultimately, it can do anything that it's programmed to. My intention is to make the goal state checker check essentially all the things about it. I will say none of these, I don't think any of these contain, well, so like my primary goal is to cover these same 11 chapters ultimately, right? I'm not necessarily intending to go too far beyond what's here. There is extra features, which is the coloring thing, paint corner, but there's no goal state here. This one is like the most minimal page, which basically just says, hey, this thing exists. It doesn't actually work in this implementation either. So probably I will do something similar where like I will make paint color work, but may not do it for the goal state. It would have to be added. Somebody else would have to add it to the goal state probably. Because none of the rest of these other pages, well, actually 10 chapters, well, and actually reference is not a chapter, so we're going to have 8 chapters, 9 is just paint, so there's no goal. So these 8 will be the only ones that I am specifically intending to actually build both the JSON files for and the ability to support functionality necessary to check the goal states on. Most likely, that's what I will end up doing. But it certainly could, from there, be extended to also check paint, and then it could also definitely be extended to, like, have whatever other stuff you wanted. Like, don't check the Karel, or do check the Karel, or don't check the beepers, or you could totally, and it'd be really relatively easy to change as well. Like, all the logic is in here, and it's ultimately just a big if statement that checks something in the goal data against something in the world object data. Okay, is that actually printing now? Yeah, and we do get false, and we get false the first time as well. Doesn't print until the end of these. False. Yeah, okay, so that's good. Let me turn this back off and see if it does get true correctly when we don't move an extra time. Get false and then move a bunch, do this stuff, and then true. Okay, perfect. Let's make sure that turning, if we turn left again, then it should be false now at the end. Cool. Yeah. And you could also make it more lenient, like if you wanted to say, you know, track Karel's location, but don't care about direction, you could totally do that as well, just by basically removing one bit of the if statement here. Just took this chunk out, then you would have it validate the XY, but not the direction. All right. Oh, that actually poses. Didn't actually pay super close attention to this one. That actually does pose a bit of a more of a challenge for us. So my implementation can't really do this the same way because the wall is being treated as the line between tiles. In my world, the wall is actually an entire tile wide. So if I wanted to do this, it would have to be 3 by 3 basically instead of 2 by 2. And then the center one on the left could be a wall. Whoops. I think that's fine. Honestly, I think it's simpler when the walls are just a tile. Could maybe oh, there's no goal on this one either. Might be in the text somewhere. We could create our own goal as well. I'll probably do it up to where we have one goal on each one, even if they don't present one in the thing here. Yeah, that one has a goal. This one has a goal. This one does is. Well, this is essentially, I suppose, the same goal as we did already. It just, this really is, this page is basically introducing turn right. It might be worth making a different goal on that page. Like making a different goal for that page, I should say, that you could do optionally. Yeah, this one is essentially solving to get to that state. Maybe we'll do like a chapter 3A and a chapter 3B. Maybe I'll do that. That way, chapter 3A, what it will be is introducing making your own turn right and trying to get the same goal state as chapter 2. And then we could do chapter 3B. I'll make my own initial state and my own goal state. And it can also make use of turn right, but it can be different, distinct from chapter 2. That way there's a little bit more to play with. And then obviously the thing about this is I'm building the framework as well. Obviously anybody else can add what I'm calling chapter objects, but like challenges, like start here and end here, and then, okay, ready, set, go, create it. What's a roadmap for making a algo bot, which operating software? Making an algo bot. I'm not sure what you mean algo bot. Yeah, I'm not sure what you mean algo bot. If you mean something related to this one, the roadmap is basically try to get initial states and goal states for the chapters that are here, and then make a learn guide out of the stuff that I have, including those states and the like framework object that makes it work. And like for the next few days to a week or so is the roadmap timeline, I guess you could say. Which operating system? I am using Ubuntu. Yeah. Okay. I will do maybe this one as well. So this is Meet Karel Chapter 1. I think I will do a Chapter 1 initial state and goal, and I'll make mine 3x3 instead of 2x2. So we want Karel to start at 0, 0, facing east. Beeper is 1 square in front. And then we'll actually have 2 from here to here. So it'll be, the code will be ever so slightly different than if you were doing this one, because this would just be moved twice, whereas ours, or this would just be moved once, whereas ours is going to be moved twice. Okay, so input is Karel, beeper. I'm actually going to also go ahead and put walls just like blocking off this little section of the world. That way we're left with a 3x3 that you can't venture outside of for this one. We'll put 6s on all of those. These can be 5s, but it doesn't really matter because you can't get to them. Maybe I'll go back and increase the sprite sheet by 1 more row and have like a null tile that's just black or white or something. That way we can have like an outside, like we can have an area that's like within our 10x10, but outside the part that this level is focusing on. Like here we're focusing on a 3x3, so really we could like, we had some null blank tile for all the rest of this, that might be nice. We will have a wall here as well. And I guess we could do it like this, where we have 2 walls, and that way you have to go... Well, no, that's not how it is, though. We don't actually need 3x3. I think I am going to do it with 2 walls. You end up with different code. It's fine. So you'll go step 1, pick up. Step 2, turn. Step 1, step 2, turn. Step 1, step 2. So our goal will be to get to there with the beeper. And Karel facing west. Ooh. Ooh. Karel and the beeper can exist on the same square. Ew. How are we going to handle that? I think we should what? We should what? We should... Okay, new plan. New plan. Karel is not going to be represented in the input world, but instead just going to say Karel X, in this case 0, Y 0, direction. Okay, yeah. That way, when we want to make the goal for this one, did have an extra one of those. We'll be able to say that there's a beeper here, and that there's also Karel there. Direction west, and that is now 0, 1, 2. Okay. Go fix those. -1 for null. Yes, we can do that, but the thing is, because we're displaying on a tile grid, we can only display tiles that are in our sprite sheet, basically. So I would also need to add, I mean, I technically I actually have this one, which I'm not using. I made this one, which is like a squares indicator thing. I don't really know what my intention was with it. Oh, you know what I was doing is I was testing what would it be like if we had these instead of this for the empty corner. But in the end, I went back to this so that we could match the original one much better. It just like offset the pluses, as you can imagine. But I could actually just block out that one, and that could be the null tile. But yeah, one way or another, we'll need a tile on the sprite sheet for it as well. Even if we were to use -1, we need a way to display it on the tile grid, which can only display the tiles inside of its sprite sheet. Okay, when we load, so this is going to be all different now. The good news is we don't have any of this stuff at all. So I think all of this just goes away. And instead, we... Oh no, I should not be checking beeper count. Oh, should I? Maybe I should. I guess I should. Because we need to... No, I mean, this works. Well, I don't know if it works, actually. I haven't tested it, but I think it's inefficient, right? We don't, because we're checking beeper count every time through this double loop, when instead we could just, after this double loop, or before, it doesn't really matter if it's after or before. It just has to come after this for sure. That part's definite. But we can just say, if that is in the input, we don't have any more and. We just say, if we have a beeper counts, then we say for beeper count in beeper counts. So that's going to be a, let's say keys. That's going to be a dictionary. So that's going to be beeper count location. I'm just going to say beeper count lock. And then count location y is 1, x is 0. And we already have, yeah, we already have a tuple, so we can just say beeper count lock. In fact, no, we have a list of lists. I wonder if I should go back and make that a dictionary with tuple, vector, keys, xy, dealy boppers. Leave it for now again, but I'm getting much closer to being convinced that should just be dictionary xy tuple keys instead of an actual two-dimensional grid. If that was, we could just copy it straight from the JSON into our one. Be nice. Okay. That should set up the beeper counts for us. We're not going to say if Karel in state. We're going to say you have to have a Karel, so it will raise an exception if there is no Karel. So we're just going to say self.karel.x equals, yep, that's the one. And then direction. Direction is tricky slightly. Direction, words, east, north, west, south, south. And then we can basically do kind of a lookup type thing there. So load, let's get back to load, self.Karel.direction equals direction words dot index of state object input Karel direction. So get the word from the state object and then find the index of that word in the list, and that will be the direction, and those map to our constants, so that will work for setting Karel, I think. Okay. That's actually pretty nice if we get to, for real, lose all of this. Let's make sure the load state works. Probably it will crash on the check goal, maybe? No, it actually died on the load state. Maybe I didn't update the JSON. I updated. Oh no, I didn't. Not in chapter 2, I didn't. Only in chapter 1. That would be 5, and this is actually different. So that's 1, and then 0, 1, 2, 3, 4, 5 is where we were at. So 1, y, 5x direction. No, east. This one. For Karel. Put it inside of input, yes, Karel. Load state 130. Oops, input. There we go. No beeper here. So Karel was up here. Karel didn't go to the right spot. My axis is actually flipped from what I'm treating it as in my head. In my head, I'm treating it as 0 zeros in the bottom left corner. In reality, in the tile grid's reality, I should say, 0, 0 is the top left corner. So I need the inverse of y, basically. So y should be the width minus the value. The height, I mean, minus the height minus 1 minus the value. World height minus 1 minus the y value. That's going to mess up the goal state as well. We're going to have to do the flippy floppy on that too. But I do think I want to do it that way because referring to it with 0, 0 in the bottom left, which is where Karel starts a lot of the time, I think makes it much simpler overall. For the user, for the person playing. More so than for me, the person writing this thing, who has to flop it. But now that we've done it and we know about it, it's fine. We ended up with 2 Karels. Why is that? So probably I forgot to take one out of the map. Why does this keep getting so big? I feel like I'm always making this smaller. Is it because I hide it and then show it and it becomes massive, but it's going to the same size? Why I'm always making that smaller. Yeah, okay. That should be. So we should basically not have any Karels in the maps anymore. They shouldn't be in the world. They should always be as their own thing here. But it does put them if they are in the world, so we got to be careful to make sure that we don't do that. There we go. Okay. It says true, but that's because I haven't gone back to fix the check state yet. And then load state is working, so we can get rid of all of this, which again is quite nice to delete that much code. So it's actually pretty cool that we put that there. And we're going to be able to do a very similar kind of thing with a lot of this, because we won't be worried about 0, 1, 2, or 3 anymore. We are doing this thing again, though, where we are doing beeper counts inside of every one of these. I'm going to comment that out, and we'll come back to it in a minute. But we shouldn't be doing that inside of the double loop here. We don't need to check beeper counts. We don't need to check beeper counts on every cell, basically. We can just go through the beeper counts at the beginning or the end. And the vast majority of levels are not even going to have beeper counts, so we'll be able to just skip it entirely. Skip it once entirely, instead of skipping it 100 times entirely. You know, I don't know if it makes a difference really, but I mean, it must make some difference. Okay, so we are gonna get the state from there. We are gonna check if the state is correct. And by state, I mean the tile index that's at that spot in the tile grid. If that's incorrect, we return false, and then we can check Karel's location. We can even do it before we loop. That way, if Karel is wrong, then we can save the entire loop. So let's just say if I'm going to say self.karel.y. Okay, and we do need to do the flippy floppy again, actually. So we're going to say same thing as before. World height -1 minus y. I'm going to put parentheses. It's not necessary. It will complain, I'm sure, but I kind of just prefer them there. If those things are not equal to, yep, that, except not input though, goal. If it's not equal to that, return false. And pretty much the same thing, except it is simpler because Karel.x is not flopped. So we can just say if x is not equal to x, then return false. So check Karel's location. X and Y, if either of them don't match, then return false, and then check the direction. So if self.karel.direction is not equal to the index of the one from the goal state, return false. So get our current direction. That's going to be a number 0, 1, 2, 3. We check that number against the index inside of the direction words of the word we found inside the goal. If they match, then they're the same. If they don't, then we return false. We get all the way to the end, we return true. We can bring the beeper counts back. Let's do them at the beginning. I feel like we do as much as we can at the beginning, because the more reasons we have to return false before we loop these two things, the more time we save, basically. Like, the more cases where we're returning false before we're looping, the essentially more time we're saving. So this will be different. We can just say if beeper counts is in the goal. We don't have any and. If it's in the goal, then we loop over all of them the same way we did here. Beeper count location, and then if beeper count lock 1, beeper count lock 0 for y and then x, and that's a list of lists, which is why we need y first. So if the beeper count that we have stored in our object does not match goal beeper counts, beeper count lock. Was I missing that before? Seems like maybe that was missing before. Yeah, so loop over all the beeper counts in the goal state, if there even are any. With their locations, we can check our list of lists, get the number out of it. If it's different than the number that is in the dictionary, we return false. Okay, perfect, I think, without testing. Let's save that. Let's see where we're at. I think that chapter 2, which is what's loaded, should be false at the end now because we turned an extra time. Yeah, okay, so let's take that turn out and make sure that it still works for true. Nice, okay. Let's do chapter 1. Oh, right. Oh, I left an extra 1 there, it looks like. And then Karel can't move there. Oh, because my code's wrong for chapter 1, and I run into the wall. We could get rid of this one from before, because we're not, like, that was because it was returning true before it had done anything, which was obviously wrong. So this one, see if I can do it from memory. So we move 1, we pick up the beeper, so that part's the same, but then we need to move again, and then we turn left, and then we move twice, and then we turn left again, and then we move twice again, and then we need to put the beeper. Then I think it should be true. And not raise the exception that we ran into the wall. Nice. I do still have an extra one? Did I not save that? Oh, I erased it from the goal state, which actually probably caused us to fail. That's funny. Yeah, that's a gotcha for anyone making levels, what I'll call levels, worlds, maps, these things, challenges, chapters, whatever you want to call them. Anyone making those will need to make sure the things that Karel can't change must be the same between your goal and your input. Otherwise, the level will be impossible to return true on the goal. Like, because I had a wall out here, but not on the goal, and because it's impossible for Karel to affect where the walls are at. Never mind the fact that he can't get through the walls to even get to the other side. It made that impossible to actually pass in the state that it was in. Be no fun for someone playing it. There we go. Oh, we still got false though. Did I put, maybe my goal is wrong on Karel? 0, 1, 2. No, that should be fine. Direction west. Okay, so let's add prints into here that print why it was false. So Karel Y incorrect. Karel X incorrect. Karel direction incorrect. I was gonna say dir. Print beeper count incorrect, and then we can say beeper count lock. Yeah, eventually we could print. I don't think we're failing that, because this should be not there, so we should be skipping this, but eventually we could maybe do like print out also the numbers that we found. Okay, so goal. Okay, so print world mismatch at y. And in fact, let me go ahead and do that here. Thank you. It's convenient. World mismatch at 1, 9. 5 does not equal 4. At 1, 9. 1, 0, 1, 2, 3, 4, 5, 8, 9. Is there a 4 up there? Oh. Okay. 1, 9 is, boy, so that that does make it a bit confusing. 1, 9 is 1, 9. Should it be 9, 1? Did I put those backwards? Well, yeah, because yeah, I did X and Y. Okay, so yeah. I did X, Y. But this is also not, this is also based on the top left, not the bottom left. So how set am I on keeping 0, 0 in the bottom left? I still feel like it's probably for the better, since Karel starts there and so many of the ones. Yeah, but that's the reason why they don't match, is because I accidentally left the beeper here. Technically, we could still pass because of the way I made it so that you can put beepers. We could pick beeper and put beeper, and then still pass, I think. We probably don't even need to pick, I guess. We could just put, or we could just pass by. Nice, yeah, that does make it pass. But it's not how we want it to be, so check out. So here, that should be a 5. Yeah, and yeah, I'm gonna leave that like that for now, but eventually I might change the way this prints if we keep this active so that it prints differently. Either 0, 0 in the bottom left, like I did for Karel's logic, or the other option well, like I did for Karel's logic inside the chapters, Karel, the object inside the code, does also treat top left as 0, 0. So when you set x, y, 0, 0, you're moving it to the top left. Maybe that's what I should change. Maybe Karel's x and y should be where the translation occurs. But Karel doesn't have a reference to the world. Karel is inside the world, but doesn't have a reference to the world, I don't think. Maybe it does, though, because it checks if you're out of bounds, but that's in the move functions. Anyway, yeah. I might either do y first and then x, since these are a list of lists, and that would make it match the data here. Or the other option would be keep it with x first and y second, but inverse the y that gets printed so that we are aligned to bottom left. But I am going to leave it for now until I actually have a need to look at it again, and then I'll decide which one I think makes more sense in the moment. Okay. Chapters 1 and 2 can both actually work. And again, it will, if we add an extra turn left, it would be false. We are currently checking the direction. Cool. Okay, so this is the one where I think I want to do a 3A and a 3B. 3A is pretty much the same as 2, so I'm going to say 3A. And in fact, 3A is literally, from this chapter object here, this point of view, it is literally the same as the chapter 2 one. The difference here is that you're encouraged to define your turn right function. But the input state and the goal, at least in this one, remain the same. Yeah. So that is 3A, and it should not require any changing. So I should be able to just go 3A and have it run and succeed. Well, it won't succeed because I have the code for chapter 1 now. Yeah. We're doing 3A, but technically the code for 2 would do it. And in fact, I already defined the turn right and did it anyway. I think these are going to make it not work. Make sure that's how it's supposed to. We moved an extra 1, and we also turned left an extra 1. There we go. All right. Yeah, the main difference between 2 and 3A is this would just be 3 turn lefts instead of a turn right. But I will make a 3B that's an actual distinct puzzle. And here we have some freedom because we're not going to do... There's not another one in here, so we get to basically make our own. So what do I want to do? So this is in the defining new functions chapter. So we could... Definitely, it should use the turn right. What's up, DJ Devin? Nice to see you, my friend. Definitely, it should use the turn right how do we make use of the turn right without just having the same exact puzzle again? We could do one where Karel starts at the tops. I mean, so far we've started mostly in the bottom left. We could start in the top and then that way turn right. We're going to come down some. In fact, how about we do this? Let's start in the top left. Let's put the beeper. I mean, maybe the beeper could just be here where it is at the end. Well, I'd like to change the walls around a bit too, though. Okay, I got an idea. Let's say Karel's here. Let's say the beeper is like up here somewhere, but there's a couple of blocks here that you have to go around. And then let's say that you want to put the beeper down here somewhere. So you will start on 0, 9, because that's bottom left based, at least right now. You can start facing east, that's fine. These will be different, so there's not going to be walls down here. That's not going to be a beeper. Instead, there's going to be walls like this, and you got to go around them. So the beeper is here. And then let's say the ending state, you want to get the beeper to down here, basically. Maybe we'll say the opposite corner. So we started one away from the corner in both directions. We'll say we end one away from the corner in both directions down there. But that needs to go to that empty. Okay. Okay, chapter 3B, let's see. Do it. What's up, Mark? I can mostly hear you over foundation work going on in my house. Oh, nice. Yeah, we did some foundation work a couple years back. It's definitely on the loud side. We did siding as well, which is loud too, but hope the foundation is okay. Never heard of Karel. Looked it up. Looks interesting. I'm coming in late. Yeah, it's pretty cool. It's pretty cool. I had not heard of it either. Somebody put the quick version of how I got into it is somebody put an issue actually years ago on the Turtle repo, saying like, hey, here's an idea for a thing to implement, and they mentioned it, and I looked it up from there. But I had not heard of it before seeing it there. Okay. Well, let's see. Can I just do this one matrix style? But we're going to start up there, so we're going to go move 1, move 2, move 3, turn right, move 1, move 2, move 3, move 4. Let's start with that. Move 3, turn right, move 4. Now we're going down. From down, we turn left. So we're going to be here, facing that way. Move 1, move 2, move 3, move 4, move 5. Turn left to go up. Move 1, move 2, move 3. Pick up the beeper. Turn around. So just left twice, we could say. Could make a turn around function. Just go turn left twice. And then, so we're here. We want to go 1, 2, 3, 4, 5, 6, 7. And then we are facing down. We want to go left, so turn right will actually get us there, I believe. Not inside there, though. And then it should be move another 7, I think. And then put beeper. And then let's also say Karel's ending position. Let's say we want to go one farther than the beeper. So you'll need to put the beeper and then also move forward 1. So that will be, it is Y1 and X0, and we'll be facing west. So put beeper and then move one more time. All right. Did we do it correctly? No. Did not even load the correct level. 3A, we want 3B. Nice. First try. No, that's not true because I failed the first try. Second try. Pretty good, though. Well, I mean, does that count? I didn't even load the right level. I don't know. It's been a while. I've been living in a deep dark hole of cryptography trying to solve Cryptos, possible level unsolved cryptogram. Stuck me in like a vortex, and I've ignored all other projects for months. I think I'm just about ready to give up and come back to CircuitPython. I gotcha. I went down the crypto rabbit hole last night a little bit. Not quite that deep, but a little bit. I was working on learned last night about Feist. I don't know how the right way to pronounce it, but Feistel cipher. It's pretty interesting. Implemented it in Python, or really I mostly found an implementation in Python. It did need to be fixed a bit though. It was pseudocodish. Kind of cool. You take the left half, the right half, you kind of change up the right half with an arbitrary function, and then XOR the result of that changed right half with the left half, and then you swap left and right, and then you can go back and forth as many times as you want, essentially. And you can also swap out that function for different things. It's pretty neat. Pretty neat concept. Didn't run into that before. But on the Crypto Tool Discord, yeah, it's not as helpful. Yeah, Crypto Tool, it's interesting. That dude, that person, I don't know their name off the top of my head. I'm not sure if they say their name in the videos or not, but yeah, they've got some really interesting videos. I've watched a few of their videos. I tried to play with the program a little bit, but it doesn't really support Linux. I tried Wine. I got it to launch, but it wasn't really, didn't seem like it was behaving correctly. I ended up giving up. It seems like a super cool program, but it doesn't seem to support Linux. Niels Kapal, okay. He's got some really interesting content on YouTube. Definitely, I think you turned me on to them. I've enjoyed lots of the YouTube stuff. And I joined the Discord around then when I was watching them on YouTube. Got a giant crack, so metal beams going. Yep. It's the same deal with me. Done some XOR stuff, but never to that one. Yeah, I saw a completely unrelated video. The video itself wasn't really about crypto, but they ended up using that Feistel cipher for what they were working on. And I was like, wait, what? The Feistel what now? And then I kind of like just stopped watching that video and went and explored the Feistel cipher and implemented it. Okay, 3A and 3B, those are looking good. Let's do validate. If we like leave off the last move, it won't be true. Make sure that that's working. False. Okay, yeah, because Karel X is incorrect. We even get to see there. Although technically, if X and Y were both incorrect, it would still only print 1, which is a bit awkward, but I think that's fine for now. You would just have to like run it twice, essentially, which actually kind of encourages iterative development anyway, so I think I actually like that, where it's like, if you are off in both directions, you get the error that you're off in one direction first, and then you kind of go change your code. Now you get the error that you're off in the other direction. You go change your code again. It's kind of like a pretty common chain of events, essentially, for programming. Okay. What is actually the next one? Composition. Composition? Okay. They're defining, okay, they're making a fill pothole. And a turnaround, in fact. This is essentially more about new functions. It's just kind of like meta new functions. The previous page like told you syntactically, here's how you make new functions, and then this page is more about like, when is it useful to make new functions, and what pieces of work make sense to break into a function. Kind of a bit more about what this page is about, sort of slightly more on the theory side than the previous page, which was a bit more on the actual like syntax nuts and bolts. Is there any other way of coding other than iterative? No, not, yeah, I mean, not really. Yeah, it's like, it's pretty much always going to be an iterative thing. I mostly just meant, though, as opposed to like, if I were to tell them that both their X and Y were off, like if I were to just say Karel's location is off, or Karel's X and Y are off, instead of only telling them one, it could be saving them an iteration, basically, because if I told them both X and Y are off, they could alter their program to fix both of them at once and then run again, which is not necessarily a bad thing. But in programming, a lot of times you get an error that says one thing is wrong, you fix that one thing, you run it again, now you get an error that says another thing is wrong. And so by breaking up the X and Y into the two checks like it is, it replicates that experience of like, it only told you one thing was wrong the first time, but actually two things were wrong. So once you fix the first one, it will still tell you, you know, that now the other thing is wrong also. Yeah, just as opposed to like saving them time, essentially, by saying, you know, both your X and Y are wrong. Okay, I think I might wrap it up here, actually, instead of doing the next one too. I'm getting kind of hungry. I think I'm gonna wrap it up and find something to eat. Yeah, I mean, there can be bugs in code. Gotta find bugs too. Yeah, I think I'm gonna wrap it up here. So then, just kind of like 4, 5, 6, 7. I'll probably try to. I'll read through this one and try to discern the goal. I guess the goal is this one. So it doesn't list it as goal, but we will. This isn't more than 10, is it? 1, 2, 3, 8, 9. Okay. Whew. Would actually be tough if that was more than 10. I mean, it wouldn't be that tough, but we don't have a camera, so we can't shift the view around right now, which would make it a bit trickier. I like to try to keep everything inside of a 10 by 10 if we can. Yeah, so that's our goal on that one. So basically 4, 5, 6, 7, 8. I need to make chapter objects for, and then I do still want to implement paint corner, which I haven't done yet, but I will. And then we'll be basically done with the code for this, I think. Yeah. All right. Take it easy, everybody. I hope you all have a good day. It was nice to see you all in the chat. Yeah, have a good rest of your weekend. I will be back next week at the normal time, 10 a.m. Central Time on Saturday. I don't know for sure about Deep Dive, so stay tuned for that. Maybe check the meeting out on Monday to see if Scott says he's going to be around or what the plan is. I'm not sure off the top of my head. I'm not sure if I'm available. I got to check my calendar for next week too. I got a couple other things coming up. So I got to check into that. But yeah, I'll be back Saturday for sure next week, I think. And yeah, maybe Deep Dive. We'll see. Otherwise, that's all for now. Thanks for watching. Hope you all have a good day. See you later.